Hello, Mr. Betts here. Let's take a look at an example that is typical with slope fields, and that is to actually draw a slope field. So in this example, I've given you a differential equation, and we want to use that differential equation at a variety of points. There's 12 points here that are indicated, and find the slopes at each point, and we're going to draw a slope line that has that slope. So you don't have to really show work for this. So, for example, at the point negative 1, 1, it wouldn't be a bad idea, except that it takes time to write out all of this with the evaluation bar and all that. So it's okay to keep it a little more formal and skip all this. But at that point, we expect to see a slope of -2. You're not going to be graded on getting this perfect, but you want to get kind of close. So if we are starting at this point with a slope of -2, we would be going toward that point right there. So I try to pick another point as a target to draw my slope line, and it's going to be something like that. It doesn't have to be perfect, but if I have a negative slope that's steeper than -2, it shouldn't look the same. It should look steeper. So I want relative slopes to look the same. I need negative slopes to obviously be negative and positive, positive, zero slopes to be horizontal. And that's kind of the big things that I'm looking for and AP graders are looking for when they grade. I'm going to jot notes down next to each problem or each point. A lot of this you might just do mentally, but make sure that you're keeping things straight, especially when you have to plug in X and Y. So on this one, we're going to have -1 minus 1 over 2. So that's going to be -1. So that slope is going to look like that. Then let's go to this point right here. We'll have -1 minus 1 over -1. So that's going to be a slope of +2, which is going to look something like that. Notice that we had a little bit of a pattern. All three of those at the same x coordinate all had a -2 in the numerator, and so we're just dividing by a different number in the denominator. Patterns like that are going to be really useful. So with all the points where x equals 0, we're going to get 0 minus 1, so we get -1 in the numerator, and then divide by the y value, so -1/2, -1 over 1, -1 over -1 is +1, and then we get our slopes that look like that. Let me draw that a little bit better. And then -1/2. So at this point here, I'm aiming for that point when I draw my slope line to get -1/2. Again, it doesn't have to be perfect, but try to get it pretty close. With the x coordinate of 1, when x equals 1, all of these slopes here are going to be 0. So this is nice and easy. We get 0, 0, 0. And then when x is 2, we're going to get 1 in the numerator. So 1 over 2, 1 over 1, 1 over -1. So a slope of 1/2 is going to look like this. Slope of 1 and a slope of -1. Let me try that again. So notice that we've got a few patterns here that I want to point out. So we got the 0 slopes here. By the way, I also want to point out we didn't even try y values of 0 because we would get 0 in the denominator. So we would expect essentially vertical lines here, but we didn't have to do that. I also want to point out that we have a diagonal here where all of the slopes are -1, with the exception of y equals 0 at least. Oops, got rid of too much there. You get the idea. We also have, we're going to have diagonals really in a lot of places. Where was the other diagonal? Here we go. So a diagonal here where the slopes are +1. So the slopes here are all going to be +1. Those sorts of things are going to indicate maybe asymptotes for certain solutions. So looking at patterns like that, we might be able to kind of get an idea of what a solution to a differential equation like this might look like. Big thing though, notice that where the slopes are 0, we have horizontal lines. Notice that the bigger the slopes are, the steeper we drew them. That is a really important thing. And try to make it as accurate as you can, but it's not